right, as we begin today, I want to start by looking at the extra credit that I assigned last night, page 153 in your textbooks, number 31 and 32, those two word problems. And to know if I could get you to go ahead and read word problem 31 for us.
The average height of two forwards in the center of the basketball team is 6 feet 8 inches. What must the average height of the two guards be so that the 5 players' average height is at least 6 feet 6 inches?
All right, so this is kind of interesting. They don't tell us anybody's heights exactly. They just tell us if you take these three guys, the forwards in the center, the big guys, they average 6 foot 8. If we want the average height on the entire team to be 6 foot 6, how tall would the two guards have to be if they were the same height? What would have to be their average height? So kind of have to think a little bit in reverse here. Let's suppose for just a moment that we have these two forwards. Let's call one SF for small forward, PF for power forward, or C for center. We would have to add them all together to get the sum of all of their heights, correct? And then we would have to take that sum and we would have to divide it by, if we're finding the average class, we'd have to divide the sum by 3, because there's 3 people. And that would give us the average, correct? But we know the average. The average height of the 3 guys is 6 feet 8 inches. So if I know the average, and I know that I divided by 3 to get it, how could I actually find the sum of these 3 guys? For instance, if I knew that 21 divided by 3 equaled 7, right? Suppose I just told you something is divided by 3 and it equals 7. How would I find the something? Multiply, right? You're the opposite of division. So same thing here. If we multiply 6 feet 8 inches by 3, I will get the sum of their heights. Does that make sense? So let's multiply 6 feet 8 inches by 3. Now it's been a while since we've done compound measures. Probably goes all the way back to last year in pre-algebra. Of course, we'll just multiply 3 times 8, class. 24 inches, and we'll multiply 3 times 6. 18 feet. But we need to convert the 24 inches into how many feet? 2 feet. Because 12 inches in a foot. And add that onto the 18 feet we already had. And really, 18 feet, 24 inches is really the same thing, class, as simply saying 20 feet. So these 3 guys together add up to 20 feet tall. Does that make sense? We also have a couple of guards. We have the point guard and we have the shooting guard. And we want to add them together to get a certain sum. We're going to take this sum and divide it by 2, and we're going to get some average for them as well, right? We could call this here, this is the sum of the 3 bigs. This sum then is the sum of the smalls. But that aside, I want the average of the whole team to be 6'6", correct? So if we took the 20-foot sum of these guys plus the sum of these guys, I want those 2 sums added together, divided by how many guys? 5 to equal 6'6". So I can take the 20-foot sum from these guys plus this sum. Well, I don't know what that sum is, do I? I also don't know what this average is. But let's call the average, since I don't know it, x. Since it does, after all, say, what must the average height of the 2 guards be? Let's call that x. Well, question. If their average is x, what's the sum of their heights? 2x. So take this sum and this sum. Add them together and divide by, we said, how many guys? 5. And that needs to be, it says at least 6'6" inches. So class, we would say at least greater than or equal to. And I don't like 6'6" because mixed measures are annoying, right? That's annoying to have to do that. 6 foot 6 inches would be more easily expressed, just say 6.5 feet, right? Or even 6.5 feet. And this is how this one would have needed to be set up. This legitimately was a very challenging problem. But does it make sense how to just kind of think everything through? Let's solve now. Let's get rid of this fraction by multiplying both sides, class, by the 5. And of course, that'll just give me 20 feet plus 2x is greater than or equal to, somebody at your seats, 6.5 times 5? $32.5 feet. Then we would need to, somebody else, guys? Subtract away the 20 feet. And that'll give us that 2x is greater than or equal to 12.5 feet. And then finally we can divide both of those by 2 to get that on average, each guard needs to be taller than 6.25 feet. Now that's one way you could express the answer. That's not the way they expressed it. You could say this, well, nothing wrong with it. You could also say 6.25 feet. But what is 1/4 of a foot? 3 inches. So we could say that each guy on average needs to be greater than or equal to 6 foot 3 inches tall. Obviously this is not referring to our basketball team. This is probably college level basketball, maybe even pro. Because there's a lot of college basketball teams that have guys shorter than 6'3" playing basketball. High schools, most guys. Questions on this? Does it make sense now? Okay. Again, a lot of thinking in reverse. Well, I don't know what their heights are. I don't even know what the sum of the heights is yet. But I know the average when I divide by 3 is this. Oh, so that's what the sum is. Regardless of how tall each of these guys is, the sum has to be this. Well, I don't know how tall these guys is. I don't know what their sum is. I don't know what the average is. Well, I do want the average, so let's just call the average x. Well, in that case, the sum is 2x. Take the two sums, that's the total sum of all the heights. Divide by 5, there's the average. Oh, now it works out. Let's take a look at an easier problem, and that is word problem 32. Read that for us if you would, Maddie. All right, so they're kind of trying to figure out, okay, how many people can we actually invite to this thing? Like, we'd like to invite everybody, but we can't afford that. So, how many people can we invite? Thoughts on how you think we should set this up? Maddie, you're the one who read it. What are you thinking now that you read it? Exactly. Guys, were you thinking the same thing as she was reading it? We've got a flat fee, we've got another flat fee, and we've got a per person cost. Okay, 18 per person has to stay less than or equal to the $2,000 budget. At your seats, solve. Let's see how many guess. Again, this one much more straightforward and much easier than the last one, right? This is why you attempt both extra credit problems. Instead of looking at the first one and being like, I got no clue, I give up. Well, look at them both. One of them was hard, one of them really pretty easy. 4 minutes of your study hall, and you get an extra credit point on your next test. And I was fully expecting this to come out to one of those where it's like less than, 152.8 guess, or we had to round because of the 0.8. No, not the case at all. Worked out evenly. And if you did it correctly, checking your work now, should have gotten fewer than or equal to 97 guess that are going to be able to come to this reception questions on this. Questions. All right. Let's go ahead and look back on the previous page now. We've been working on graphing linear inequalities. And say we graph it like a linear equation, right? We generally will use slope-intercept form class, which is good bracket, y equals mx plus b. The difference is there's just not an equal sign, right? But otherwise, we still plot this y-intercept. We rise and run. We connect the dots, but that's one of the differences. We don't always connect the dots with a line. Sometimes, class, we have to use a dashed or dotted line. No, when would we have to use that one? When there's not a little or equal to thing with it, right? But if there is the little or equal to thing, Brecken, then just use the ordinary solid line, right? But again, the key is that line really isn't even the main feature. The line is simply a boundary between two sides of a graph. And the key thing really is shading one of those sides. Maddie, how do we know which side to shade? Okay, you test 0, 0, which we're going to look at several examples here in just a moment where you can't. But in general, you pick a test value. 0, 0 is the easiest, right? And you plug in 0 for x, 0 for y, and you see if you have a true statement or a lie. And let's suppose, Maddie, we plug in 0, 0, and we're like, yeah, that's true. Then what do we do? What point thing? The origin, yeah. So whichever side the origin is on, whichever side 0, 0, the point you plugged in is, you shade that side. But what if you plug in 0, 0, Maddie, and you're like, no, that's a lie? You shade the other side, right? The side that doesn't have the origin on it. Now look with me, if you would, at number 9. They give us this inequality, y is less than negative x. Notice here, this is in slope-intercept form. Y equals, or something, m. What is m here, class? Negative 1 over 1 x plus b. What is b? I don't see it, which means it must be nothing. Or in other words, 0. When you don't see a constant value, that is your b. Does that make sense? So I know, real quick, if I'm going to graph this, we'll just do a quick sketch for sake of time. My y-intercept, class, is 0, right? So well, that means the origin, which is the 0 of the y-axis. From there, I should rise 1, run backward 1. And I'm going to connect these with a, I'm going to connect these with what kind of line? A dashed line, because I don't have an or equal to, as Noah told us earlier. But you realize you can't test the origin now, can you? So my suggestion was, I've got a point right here that would be easy to test, 1, 0, or I could test this point, 0, 1. Either one of those would be easy to test, right? Which one do you like, Brecken? 1, 0, why not? So that means we need to plug a 1 in for the x. So again, going back to y is less than negative x, plug a 1 in here, plug a 0 in here. Class, is 0 less than negative 1? No. So that means this point is a lie, which means shade the other side. You see how it's still fairly easy to operate, even if 0, 0 is knocked out of the idea, right? Okay, I couldn't use 0, 0, not the end of the world. 1, 0 is pretty easy to use also. I mean, 1, 1 would be easy to use for that matter, right? So there are options if the y-intercept happens to be 0. Look at number 11. Y is greater than or equal to 3x. Well, again, that's kind of in slope-intercept form. I've got my y something mx plus b. Once again, class, the b is 0 because I don't see it. And the slope is 3 over 1. So I plot my y-intercept at 0, or the origin. I rise 3 this time, run forward 1, and connect with a solid line. I've got that little or equal to. So I connect here. And then again, I need to pick a point aside to shade. Give me a test value. Why not, right? 1, 0 is a good test value. Remember, the 1 is the x, the 0 is the y. Okay? 0 is greater than 3. No, liar. So that means this doesn't work. Shade the other side. Make sense? Still seem pretty easy? All right, look at number 13. We've got a y is less than or equal to 2. Whoa. To 2? Realize this is the b. There's no x here. In fact, if we wanted to, we could say y is less than or equal to 0x plus 2. Does that make sense? So, my y-intercept class is 2. From there, I need to rise 0 and run 1. Rise nothing, run 1. And then connect the dots with a solid line. So, you said it's a perfectly horizontal line. Well, yeah, remember if the slope's 0, you get a horizontal line. Well, notice this time, my 0, 0 is right here available for use. Not that there's a place to plug it in here, mind you, but you could say 0 is less than or equal to, well, that's already nothing, plus 2. Is that true? Yeah. So that means the origin works. So we shade everything down here. Notice there wasn't an x, only a y. Well, these are your y values. This is y value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? Here's y is 2. Here's everything smaller than a y value of 2. Does that make sense? Now look at number 15. We've got x is greater than or equal to 1. Technically, we could say 0y is greater than or equal to negative 1 over 1x, or negative 1x plus 1. But then we'd have to divide everything by 0. Are you allowed to have 0 denominators? No, so we can clearly see here my slope class is going to be undefined. You can't have 0 denominator. So remember, a vertical line rises but never runs. So when you see this form, you know you're looking at a vertical line, which also, by the way, has an undefined y-intercept, meaning there isn't a y-intercept. Well, of course not. If it's a vertical line, it's never going to cross the y-axis. They're going to be parallel to each other, correct? So at this point, we've got to ditch the whole slope-intercept form and picture this. Here's my graph. I know I'm going to get a vertical line. The question is where to put it. Well, x is everything greater than or equal to 1. So you know where my boundary line is going to go? Wherever x is 1. And that's where I'm going to put a solid line. But x is bigger than 1. Are these x values bigger than 1? Are these x values bigger than 1? Yeah. And that side of the graph gets shaded in. Now, those are a little bit more weird. That's getting into a little bit more Algebra 2 level, okay, just to be fair, okay, where you're missing a letter from the linear equation. But I wanted to show you what that looks like so that next year's not the first time you've seen it. Questions on that? Does this sort of make some level of intuitive sense, hopefully? All right, let me have you practice, though, some of these now. I want you to do numbers 2 through 12 of the even. And tell you what we'll do for sake of time. You still use your graph paper, but instead of taking time to set up all the increments, just draw your quick axes and roll from there. I don't think we need to do the full labeling just for sake of time, because you're literally going to have to do 6 different Cartesian planes here. So we'll try to make it as quick and easy as possible. Page 152, doing 2 through 12 of the even. Again, slope-intercept form if you can. Again, the only time we haven't been able to do slope-intercept form is when they give you x something constant. And of course, that'll be a vertical line. But I don't think you've got that in these. So 2 through 12 even. Give you a few minutes to get a head start, and then I'll put these on the board and we can check our work. Now check your answers or your work on 2, 4, and 6. 2, 4, and 6. Did you get lines that look like that? Shading that looks like this. Start with 2. How many could go on 2? Good. Number 4. We're good to go on 4. All right, and then number 6. Good to go on 6. All right, keep working. So we feel like we've pretty much got this down then, it seems. Got practice just those few more. Make sure we've really got it. Probably on number 8, the intercept method would have been easier. Oh well. Now for sake of time now, if you would, go ahead and check your work on 8, 10, and 12. Even if you're not finished with all of them, let's go ahead and take a look. I really wish I'd done the intercept method here, just to be quite honest. Plug in a 0 for the y. 5x is less than 10. The x value here is a 2. Then plug in a 0 for the x. Move the 2y over, get 2y less than 10. Y's value is 5. Plot my 5 and my 2. Probably would have been quicker than all of this, especially since I went up to really the top end of the graph to try to make that happen. I just could have gone down 5 and forward 2. Would have had the same two values. Dotted line, try to plug in 0, 0. Again, going back to the original, 0 less than 10 minus 0. That is true. So I shade beside that as the origin. Good to go on 8. Number 10, it says y is greater than x. Looks really nice, small, and easy. You actually have to uneasify it a little bit here. Make this a 1 over 1 so we can see the slope. And I would tack on the plus 0 so we see that 0 is my intercept. Rise 1, run 1, connect with a dashed line. I tried right here, the 1, 0. Plug in a 1, plug in a 0. Is 0 bigger than 1? No. So don't shade this side, shade the other side. And do we get that for 10? Okay, did you not make it that far or didn't get that?
I didn't get that.
All right, does it make sense what I did as far as kind of fleshing this thing out? You almost didn't have enough here. Needed to see a little bit more. Does that make sense? There isn't a constant, so tack on a plus 0. The 1 is understood. Go ahead and write it in so you can see it. Does that make sense? All right. Questions on plugging in the 1, 0? Questions at all? All right, Maddie, did you indicate you were good to go on this one? And then the last one, similar idea, just divide away the 3, and then I also tacked on a plus 0 here. So again, there's my intercept, rise 2, go backward 3, dashed or dotted line. I tried 1, 0 again. There's the 1, there's the 0, gives me 0 is less than negative 2. That's not true. So again, don't shade that side, shade the other side, and we're good to go there. Did we get that for 12 if we made it that far? Questions? All right, look across the page now, page 153. And I want you to work on numbers 14 through 20 for the even. We are finally ready to wrap up this chapter on inequalities. Ready to fully wrap the chapter here. And so on page 153, let's wrap with some of the more challenging inequalities we've dealt with. Those compound inequalities and those absolute value inequalities that still, for some of us, given us fits. So let's get a little bit more practice in here. Just about ready to close the door on this chapter and move into chapter 5. is finished. Maddie checking your answers. Good, got all of them. Excellent. 6 for 6. No, are you checking or working still? Working, that's fine. Ready, finished? All right, checking your answers now. Pretty good. Excellent. All right, for sake of time, Noah, go ahead and stop where you're at. Let's take a look at these together now. On this first one, very straightforward. Add 4 to everything, divide everything by 3, -1 less than x less than 2. Super simple. I assume we all got this first one. The next one, not quite as super simple, though essentially the same steps, right? Subtract 1 this time from everything, then divide by -2. You've got to remember, when you divide by negative, these inequality symbols have to flip around. And, of course, the signs are going to end up changing, right? This becomes a positive 2, becomes a positive x, becomes a -4. And then you have to flip the whole thing around. The -4 is now less than x, which is less than 2. And it all kind of flips around there. Did we get that for 16? All right, on the next one, absolute value. Draw the number line once the absolute value is isolated. Put your positive negative. And then this either goes between or outside. Since it's less than, it goes between. So you get one compound inequality. Now notice, every correctly written compound inequality is less than, less than, less than, less than, less than. That's the way it's supposed to be. So since it's one inequality, -30 is less than 2x plus 5 is less than 13. Progressively getting bigger. And then you just solve like a normal compound inequality. Did we get this on number 18? For the next one, it's a greater than. So again, it's isolated, number line, positive, -5, but put the 3x minus 7s on the outer ranges. You're going to have two separate inequalities, not a compound inequality. You're going to have 3x minus 7 is smaller than the -5, or equal to. Or 3x minus 7 is greater than or equal to the positive 5. You solve them each separately as their own little inequalities. You get x is smaller than or equal to 2/3, or x is greater than or equal to 4. Did we get this on 20? Excellent. Here, did we get no solution or we start solving it? How many started solving it? How many recognized immediately no solution? What if it had said greater than? Would it still be no solution? No, what would it be then, class? All real numbers. Okay, so if it's greater than a negative, all real numbers, less than a negative, no solution. The only way you have to worry about it is if you have a positive over here, which we normally do. Over here, the last one, is kind of at everything. You have to subtract the 3, divide the 2, get to this point, set up your number line with a positive -21, less than, drops it inside, and now add the 3 everywhere, divide by -8. So again, signs change and inequality symbols change to become greater than. You're not supposed to have greater than, you're supposed to have less than. flip the whole thing around to get the negative 3 less than x less than 9/4. No, it did not finish the last one, correct? But does it make sense? Any questions on that? And you two said you got that, correct? And of course, Gavin, if at any point you had questions, again, reach out to me, have Mom email me. We can do some video chat to help you there. As we finish out the hour here, I want you to do just 2 more problems here. Page 153. Page 153. I want you to do 26 and 27. 26 and 27. They're on page 153. Do a separate graph grid. Go ahead and set up a full Cartesian plane this time, just for the practice sake. So on quizzes or tests or something, we wouldn't, fail to set things up correctly. Don't want to get out of practice. Page 153, 26 and 27, a separate Cartesian plane for each. Go into a full Cartesian plane. .26 isn't pretty. That y-intercept is a bit of a pain. You went down, which takes care of the negatives. Then you have to run opposite. You have to run the positive run. But yeah, good job with the 1/3, and even dropping down. Though it looks more like a half you dropped. No, that's right. That's right. So the 1/3. It's a little under the half. So just went the wrong direction with it. But you did recognize 0, 0 didn't satisfy. Good. 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 And of course 27 is pretty straightforward. And did we get this for 27 then? All right, tomorrow we are going to have a quiz over graphing linear inequalities. There will also be some more practice with absolute value inequalities, compound inequalities. So make sure you are ready to go for that quiz tomorrow. Your homework for this evening is to read pages 154 to 157. Now obviously tomorrow it's a little bit of a shorter period because of the special short early dismissal, and of course then we got spring break off. So I don't want to get too far into our new unit tomorrow, just kind of a preview tomorrow of what's coming. But so read over pages 154 to 157. Then page 158, much of the homework will prepare you for the quiz tomorrow. Page 158, do the review, 5 through 10, 13, and 14. Page 158, the review, numbers 5 through 10, 13, and 14. And as needed, go back and study example problems to be ready for the quiz tomorrow. All right, you are dismissed. Have a wonderful rest of your day.